Welcome to e-learning. This time is Vapor Part 2. The building component consists of a double glazed window, and what we have to do is to figure out if there's going to form a layer of condensation on the window at the layer called I,1 when the relative humidity inside the room is 70%. The thickness of the glass is 2 mm, and the thickness of the air between the two glasses is 10 mm. The temperature inside and outside are as always set according to the design temperatures given in DS 418. We have the manual to help us, and we have to do the left-hand side part first before we can move on to what we actually have to do, and that is to find if there's condensation at layer I,1. And to do that, we must use a table, and we must use the knowledge about relative humidity internal. Finally, we go to the last packages, and then what is important is the first equation, and that says that actual pressure in internal is equal to actual pressure in layer I,1. What is in between, this is what we're going to do in Vapor Part 3. As always, we start with writing up the problem. And as you can see, I have figured out what is the temperature in the first intermediate layer, meaning I have been doing the packages in the first row. And that was 13.4 degrees Celsius. So what I have to do is I have to find Psat at the temperature in the first intermediate layer, and to do that I need a table. I look at the table showing corresponding values of temperature and vapor pressure, and you can see that we are between 13 and 14 degrees, which gives us a saturated amount of water vapor at around 1580 pascals. In the problem, I have written in what was the saturated amount of water vapor, and it was 1580 pascals. So what I have to do now is I again have to go back to my table and look up what is the saturated amount of water vapor at 20 degrees. The saturated amount of water vapor at 20 degrees can be looked up in the table to be 2338 pascals. So what I have to do now is I have to use the formula, because I have to figure out what is the actual pressure internal when I know the internal relative humidity being 70% and using the saturated amount of water vapor at 20. I fill in with numbers 0.7 times 2338 pascals, and that is equal to 1637 pascals. What I have to do now is I have to compare P saturated at I,1 with P actual internal, and we remember that the actual internal is the same as the pressure in the layer I,1. I've been writing up the values, and you can see that Psat is less than P actual, and that always leads to condensation. So we have condensation at layer I,1.